Very good morning to one and all. Today we are going to see a small problem on superposition theorem. Find the current IPQ by using the superposition theorem. So here is a circuit. So here if you see two voltage sources are given. It is 125 volts and 62.5. So here the resistance are given here 12.5 ohms, 25 ohms, and 37.5 ohms, 12.5 ohms like that. So by seeing here clearly, you can understand there are three loops are available. Okay, one, two, and three loops. So current I am taking in this direction. So regularly we'll use this direction, that is clockwise direction. So directly we are taking this loop current as I1 here, I2 here, I3 here. Okay, so we need to find out the current across this 25 ohms, that is this current PQ, point PQ we need to find out. How to find out? By using the mesh analysis or loop analysis. So in the loop one, so what is the current you need to find out? That is if you find out this side, okay, from this side if you start, so 12.5 into I1, yeah, I1 plus 37.5. Yeah, here it is 37.5. No? Here it is 37.5, I1 minus I. Okay, I1 minus I3, and current flowing in this direction. So here we are taking this equal to minus 125, equal to minus 125, or plus 125 is equal to 0. Like that also you can take. And simplifying this, we are getting this equation as equation 1 as 50 I1 minus 37.5 uh, I3 is equal to minus 125. This is the equation from the loop 1. So coming to the loop 2, how to calculate the loop 2? Yeah, in this loop 2, the current is flowing from minus to plus. So minus to plus, we are taking this, it is minus 125, minus 125 plus 12.5 into I2 minus I3. So here again, coming to this point, it is 25 I2, 25 I2, so equal to 0. So that we are taking. So here minus 125 we are taking to this side. So it is plus 125. So 25 I2 plus 12.5 into I2 minus I3 is equal to 125. So simple, while simplifying, you get the equation as 37.5 I2 minus 12.5 I3 is equal to 125. So take this as equation number 2. Next, again, by applying the KCL in the loop 3, okay, loop 3, that is mesh analysis in the loop 3. So again, the same thing. Yeah, here while applying here, it is 37.5 I3 minus I1. So it is current is flowing in minus 2 plus. Okay, so minus 2 plus is minus 62.5. So again, it is 12.5 I3 minus I2 is equal to 0. That's all. So yeah, equal to 0. Again, so what we are doing is we are simply, so first what we are considering is we are considering 125 volt only acting. Okay, so here we are considering only this voltage source only acting. So this voltage source we need to short circuit. So the rule is short circuit the voltage source. So we are not considering the 62.5. So now we are finding out the, yeah, now we are finding out the loop current. So while solving the KCL in loop 3, so while simplifying, we are getting the equation like this: minus 37.5 I1 minus 12.5 I2 minus 50 I3 is equal to 0. Take this as equation number 3. Okay, solving this all three equation by your scientific calculator. In scientific calculator, how to solve in the sense, open the mode. Okay, mode in that the equation is there. Okay, in the equation, so if you are using FX 991 ES plus calculator, so in that the equation is 5. In some other latest calculation, you get the equation alone. In that, if you go, that will be asking how many one unknown or two unknowns like that. So here we are having three unknowns. So like that, it will be asked. So In that calculator, scientific calculator, you need to go for a which say for example what say for example equation number in the mode go to mode in that a particular equation is there. Okay, 5, if you 5 plus 5 equation will come. So in that you can solve that equations. Okay, so how many unknowns, that also, say for example I'm taking this second equation. Second equation is in the form of a n x plus b n y plus c n z is equal to d. So three unknowns are there. So if you just put all these values there in the matrix, automatically you'll be giving the answer. So I1 is while solving I1 we are getting as I1 is equal to minus 4.70 amperes. Then I2 is equal to 2.35 amperes. I3 is equal to minus 2.94 amperes. Next part again, when source 62.5 voltage alone is active. Okay, now we need to consider this source alone acting. This source we need to short. Okay, say for example, if the current source is there, we need to open circuit. So that is the okay. Open circuit the current source and short circuit the voltage source. So here, say for example, only 62.5 source alone acting. Now again, we need to find out from the loop one. So loop one will be same will be coming. So this is the same equation. Sorry, loop one's not same equation. So without the 125 will be we need to take. So it's the same equation not same. That is 50 I1 minus 37.5 I3 is equal to 0 instead of 125 because we have short circuited the 125. No, so it is 0. So now we get the equation. So from the loop 2 I think almost same, but here the 125 volt will not come. So the 125 volt we are taking the zeros. So that is the same equation will come. So loop 3. So we'll apply for loop 3. So here 62.5, here minus 62.5 here will come. So if you go to right hand side, it will, if you take that to right hand side, it is plus 62.5. So here 62.5 alone will come. Solving these three equations by using the scientific calculator, so you'll get the answer as I1 answer as 2.65 amperes, I2 as 1.17 amperes, and I3 as 3.52 amperes. So what is the current across the particular point PQ in the sensor? So if you see the circuit here, yeah, if you see the circuit here, so you need this current alone, that is current I2 alone. So this current you need, this point, 2 points only you use. So this current will flow like this, okay, like this to 25 ohms. So the points are here. So we need I2 current, okay. So two I2 currents we have. That is whenever the 125 volt is operating, that I2 that current you have, and whenever only 62.5 volt alone acting, that current also you need to add. That's all. That means when 62.5 volts acting, so IPQ, that is I2 is nothing but 1.1765 amperes. When 125 volts alone is acting, the IPQ is nothing but 2.35. Yeah. So here 2.35 amps. So that you need to add. So that is the total current flowing in the PQ. That is IPQ is equal to 3.52, approximately 3.52 amps. So this is the answer for this particular circuit. That is current flowing in this particular is 3.25 amperes is the current flowing in particular point, that is P and Q.